Yeah. What?
So that works.
I'll see him.
So I got 2 points back, and I got 2 points back.
There we go.
Okay. Did anybody not get that handout from last time? Yeah, we had to go over it today. We didn't go over that. All right. So before we go over this handout, any questions from homework? Yeah.
Just to make sure, 5.3, 68, just approximately area.
Oh, sorry. I was hoping I was you. 5.3.
68, I mean, just approximate the areas. And then finding maximum or minimum.
Oh yeah. Okay. Okay. So let's look at this real quick. Yeah. This kind of question. I thought they asked, sort of like what they asked before. Yeah, but this is a little more into it than that first question. You were there. Come back. Come back. No. Yeah, it's the definition of insanity. There you are. Alright, where'd you go? There you are. So there's a question earlier in this section that sort of sounds like this, but they ask you simpler kind of question. Anytime I say simpler, I mean relatively. Alright. So they say let g of x equal that area function, right? Poor little dude, get in there. So, from 0 to x. So, for example, for how long roughly would you say that starting at 0, the value of g of x is what? Like at this point, is it positive or negative? Positive. So roughly about where does it become 0, would you think, first? Well, at 1, it's collected all this area.
0.5?
Do you see what I'm saying? At 1. So anywhere in between here, it is positive, obviously, because I've got positive area that I'm collecting. You guys kind of with me? So at this point, the area function is the area of that little bump. So how far past this do I have to go? I have to go until I have a nearly equivalent amount of negative area to cancel it out. Does that make sense? So it's sort of related to the first roughly the first problem in that section. So now this is asking something different. This is saying what values of x where the local maximum. So really interpret what that means. At what x point is it the largest area that it could accumulate from 0 up to that x point? So obviously, probably not here, although it is positive. Once it's here, it's what? Decently big negative, right? It's definitely more negative than it was positive here because it's lost all this area, right? But then it gains all this area, and then it loses all area, and then it gains all that area. Oof. So you have to figure out, this kind of thing where if you get to about here, it would be 0 again, right? I like it. And then you get this much negative, and then you get this much positive. So then you're like right here, would it be positive or negative? Definitely positive, because you've overcome this negative. with this and this, right? Okay. So you do have to kind of feel out, and you can estimate. You can tell me how you estimate it. You have to feel out when is the area going to be the biggest as you move along. So obviously you're not going to be here because I just lost a lot of area there, right?
Yeah.
I like it. So it's probably going to be somewhere where? Where's the area going to be the most? Not here, because that occurs after it's been negative. So probably at a point where it just stopped being positive, like right there, maybe, or there, there. One of these points. That's got to be one of those is going to be the. Does that make sense? That's one of those is going to be the maximum area it's collected so far. So when I see the integral from 0 to x, that means the area I've collected from 0 up to some x value that you tell me. That's what that means. Collecting that much area. It's the total area under the curve. That could be negative. All right, so at least you kind of have a view. You know how to look at this problem, how to figure this out. Does it get weirder than that? Let's see. Where does G attain its absolute maximum value? Oh, I guess it gave away part A. I didn't realize. Those are the local maxes we just did, right?
Yeah.
Does it make sense? Because, what's going to happen is the area is going up and up and up and up, and the minute it hits here, the area now is... What am I gaining area or losing area? Losing. So that's why it's going up and coming down. That's why that's a max. It's a local max. All right, so I just accidentally did half of part A for you. Local mins, same idea. Alternate location, yeah. Part B, you just got to figure out, that's what I thought part A was about. Which one of those local maxes is going to be the most maximum? Part C is neat. I like that. Oh, that's going to take a little bit of thought, right? Because what I was just talking about was related to what? So like here, the area is getting bigger or smaller as I go from here this way. Yeah, I'm gaining more area, so that's a positive slope here, right?
Yeah.
And then here the area slope would be right there. Am I gaining or losing area right there? Neither, so it's flat. Do you guys, so how do I say this? This is not a graph of G, right? This is a graph of F. But what would G look like? It would be going up as I move across here. It would be going down as I move across here. So right there, it's not going up or down. And we already knew that. We identified this as a max, a local max. Shoop, and then it goes back and start losing area. So concavity is what? What is concavity? You're all like, a horrible nightmare I had. Don't you dare. Okay. So, we know, it doesn't really matter what it looks like. All right. Shwa. So it's really easy to tell where it's, f prime is greater than 0, f prime is less than 0, right? So now they're asking me, where's a concave downward? The result, well, this is concave down in between here, right? Why? Because I'm losing, I'm not gaining as much anymore. Right? I mean, it's how do I say this? So where does it start to be concave up?
Whatever that
Right after it's the most negative slope, right? Right after where it's the most negative slope. All right, that's related to that bonus question I asked on one of these tests. Where is it the most negative? It was the second derivative you had to look at. So you have to think about not only where is the slope positive or negative, but where is it the most positive? Where is it the most negative? Those are going to be your inflection points. Okay. There's so much to love about this problem from my perspective. So much to hate from yours, but you got to really kind of go through this. This is the kind of stuff that you should pick up on the way here about what exactly is concavity. Why is that an inflection point? Right before it, it's the most negative slope. Right after it, it's not as negative anymore. So that inflection points could be the location of most negative or most positive slope. Okay, this one adds a layer of difficulty on it. Oh yeah, that's not the function. You got to think about what the area is doing. I like it. All right, so that's definitely one of the harder problems. One of the harder problems in there. So you got to give that a try. Anything else from homework? Yes.
5.4, number 18.
Ooh, I like it. I would. This is before. So anything up to 5.4 is before we learn any tricks of integration, right? U sub, you can think of it as a trick, but it's a process. But this is before we even get to U sub in 5.4. So they give you this. It's possible we talked about this. I can't remember now, but we talked about something like this at least. Because what's one of the themes of the semester courses? Simplify first if you can.
Two sin x or
Yeah, so you use a trig identity, 2 sin x, cosine x, over sin x, and see the sin x's go away.
so 2 sin x plus
Yeah, so you get 2 cosine x, and you can integrate that. No problem. Cool. Same thing you do with, so today we're going to do something harder than this, but if you ever see something like this here, I'll just use x, Jeff. Yummy, yummy.
simplify.
What would you do?
Like
Yeah, simplify. Why can you simplify?
Because it's all X.
x.
More than that. The bottom is
It's by itself.
one term. So then I can split it up, split it up, split it up, and reduce. Right? So that's easy. Then it becomes a power rule. You look for your power rules because that's an easy rule. It's like, oh yes.
Yeah, I wanted to take a look at the sheet that you gave me with secant, like sine x over cosine square x.
Oh yeah, okay, we're getting there. Don't worry. We haven't looked at that yet. So anything else from homework before we do this handout?
5.454.
Honeybees, let's see. Blah, blah, blah. Oh, okay, I like it. So this is that, let's look at the heart of this problem. It says the number of honeybees is, yeah, okay, cool. So N is the number of honeybees in some certain week. Then what's N prime of T?
The rate of change in honeybee?
Yeah, because how can I rewrite this? Would this be dN dt? So it's the rate of change of the number per week. Right, if T is in weeks. Right, so they tell me that, and they tell me directly that N prime of T is the rate of change per week of these honeybees. Right. Cool. So then what the hell would this mean?
The number of honeybees between the 0 and 15th week?
Yeah, the number, the pure change, the number of bees that it changed by over the first 15 weeks. Yeah. Is that cool?
Yeah.
So that's the heart of the problem. They got some extra crap about you started with 100. You better start with some honeybees, or I'm not sure what's going on. Honeybee creation, right?
Okay,
Oh, I am the immaculate honeybee. No, I don't know. Get into honeybee religion. I have no idea what that would be. Honeybees. All right. So that's number 54 in section 5.4. That's that net change theorem, which is just silly. And if you integrate a rate, you add up how much it's changed, you get the total change it made over the whatever time. That's what you get when you integrate a rate. When you integrate a velocity, you're going to end up with position. That'll be your total displacement over whatever time period. Okay, cool. I like it. It's almost kind of silly. I mean, here, I remember somebody asked something about where the dt goes yesterday, which is a good question, because this is the first time we've ever seen notation like this. I used to call this bookmark notation. Like, these just go away. This is the thing that I actually operate on. But it's more than that. What is it with this? I like thinking about it's more accurate actually. I think that this is just multiplying together to make an area, right? Because that's what you're doing. And sure enough, if that was what was this? This is number of bees per week. And what's DT? What units is DT in? Time, which in this case was weeks. So sure enough, what do you get when you multiply this? Total number of bees. Yeah, that's crazy. I mean, that's just come on, that's crazy. So this isn't truly. I used to teach this, and it wasn't wrong, but I used to teach this as like a bookend symbol. But this truly does have a purpose besides just sitting there going, "I'm a bookend." It's when you multiply these together, you get the area. That's why this disappears in the process. It integrates with this. Right? And then there was a holy shit moment. Oh, that's why they call it that. Okay. All right. Anything else before we get to this?
So, and with substitution, so if we add something and like subtract something, I mean, what happens to it if it has x? Is it?
I'm not sure. I know exactly what you mean. Do you have an example?
It's the same example, sin x or cosine x.
Okay. Let's do the handout. That's basically what you're saying, Johnson. Just do the damn handout, John. Shit.
Number 8, you also look at the square root x squared plus 1 as x in motion. Absolute x.
What did I just do? I'm smart. Do it again.
So AD, there's x squared multiplied by square root x squared plus 1.
Oh, AD, yeah. All right. That's the way you did it, Jeff. All right, I'm sorry. So AD. All right. Let's get there. Let's get there. I appreciate your passion, Jeff. All right. So if you weren't here last time, I feel bad for you because I'm not necessarily going to go through all this again. You desperately want to watch the video if you weren't here last time. Use substitution is a cornerstone in basic integration. You just basically always pray it's U sub. If you have some ugly integral, please be U sub. I'm not saying the other processes are that much worse. It's just that U sub is just so nice. And right now you don't believe me. I understand. How do you know when you have to use U sub? Is if you can identify an inside part of the function. So for this for the example, what's the inside of a function? What's on the inside? Yeah, that's inside a ninth power. This is fine. That's just x squared. It's not. It wouldn't need a chain rule itself. So since U sub is an answer to chain rule, you can sort of look at it as, well, what part of my integral would require a chain rule? You can start there. It's not always going to be the answer, but it's a good place to start and try something. So here I let u be x cubed plus 5. du is 3x squared. Now here's something cool. This is what I haven't really done too much of yet. Let me look at this here. Let's really tease out what the hell I did. So I've got, there it is. So, let's do this. Integral x cubed plus 5. So if I let u be the inside, then du is
3x squared.
Yeah, du is 3x squared. dx.
So
Do I have 3x squared dx?
no, we haven't.
There are many, many ways to do this. Obviously, I'm biased about what I'm about to say, and I kind of know math, and I kind of know where you're going possibly if you're going into Calc 2. And I know where you're going this semester, so it's so much better right now to just do it this way. And it just makes so much sense, too. There's no vagueness about it. What am I missing? I'm missing a 3. So if I put a 3 there, on the outside I better put 1/3. So overall, I didn't do shit. Right? Yes?
You've just been able to divide the du by 3 also, right?
Yes, but that... I was about to do Yoda. Leads you down the dark. But it's the wrong path to take.
The dark side, you press the
Alright, sorry. Because then people start dividing by x's too. And the minute you start doing that, you start, like, why does this work? The easiest way to make this not work is to have it start off like this. Alright, I just know that that can work, but I have to do something heinous. Why is it not going to work the way I hope?
I think we're just.
Because the derivative of this would be x squared. And I can't introduce an x that I don't already have. I can do numbers all. This is what I mean by numbers. If I'm off by a coefficient, I'm not off. I just can put, if I need a 7, I put a 1 over 7 outside. So overall, I didn't do anything. But if I need an x, I can't put a 1 over x outside. We know that. We can't have an x go across that boundary. We can't do that. So when you start doing stuff like that, it starts to become full-blown just solve for dx. Because that's you could solve for dx, and then and then just replace dx with this. But you see, that leads people to think I could do anything then, and that's not. Unfortunately, that's not true. Do you understand what I'm saying? Mm-hmm. So if you're careful, that method will work beautifully. It will work beautifully. But you got to be really careful, and this process just lends you to not be careful. Like, I'll just always solve for dx. What's the big deal? Sometimes it won't work. That's the big deal. Okay.
Are you going to give us something right there on the bottom? On the test?
Not on the test, no, because that would be remarkably evil. Because then you spend forever, I couldn't get that one, I didn't quit. Well, that was impossible, man. And then you have every right to punch me in the face. Yes, it's on record. Right? If I give you one like that, then I'm like, oh yeah, that wasn't you, just had to say can't do
This
that.
video doesn't matter.
Screw that, that's evil.
He's gonna take it down easy.
Yeah, I gotta go. Alright, you have it on record. Alright. But now going back up to this. So I let my u be the inside. Did my du. Don't do this crap. Now I have 3x squared dx, and what is that? Du. Right? That could be du. 1/3 integral, and what's x cubed plus 5? U. So that looks really nice. I can do that using the power rule. Right? So coming back to this, that's exactly what I've got here. U to the 9th, and then I get u to the 10th over 10, which multiplies to the 3 that was already there, so forth. Right? So it's undoing chain rule. That's why the first thing I got to do is repackage the inside function, because that's what made the outside stuff show up. Hopeful. So, let me get to John's questions before he goes crazy. So here, what would happen on this first one?
So substitute.
What's on the inside?
3x to the 5th.
Good. So if I let u be 3x to the 5th plus 1, what's du?
15x.
15x to the 4th. Thank God, because I have an x to the 4th there, right? I gotta have that x piece there, or u sub will not work. So, of course, what am I missing? 15. So how am I going to rewrite this integral? 1 over 15 integral u to the 6th, and then it would be 15. So if I put 1 over 15, it would be 15 there, and that would be du. Again, if you missed yesterday, that seems like magic, baby. I don't know. I'm not going to go through that lecture again. And then how do you integrate that?
1 over
U7
over
7.
7. And of course, u was...
U7
Oh, let's go ahead and do this. What's 7 times 15?
100.
105. U was 3x to the 5th plus 1. Wow! To the 7th plus 2. Good work. Alright. Just always, if you started with x's, you better end with x's. Don't tell me the answer is in u's. What the hell's that? So you guys try this second one. Try part B. Yes.
Why did you add the number, like CE or 15? Just didn't get it.
This one?
Yeah.
What does DU need to show up? It needs 15x to the fourth dx. Did I have 15x to the fourth dx? So if I see 15x to the fourth dx, I can replace it with du. If I don't see it, because of some number, well then I just force the number to show up. So if I put a 1 over 15 outside, that allows me to put a 15 inside. And something I was thinking about, let me see what you guys think about this. Maybe I'll do that with part B here. What happened? I'm sorry. So in part B, let me show you something on part B. Let's see if this works out. So what am I going to let u equal here?
X cubed plus 1.
And do you see, this isn't always true, but it's true very often. What about this tells me that u sub will work?
The derivative.
The derivative of the inside is there, minus a constant, but again, who cares about constants? You do want the right constants, but you don't need them to be able to do it. You can put them there if you want them. So if u is x cubed plus 1, du is?
3x squared dx.
Do I have 3x squared dx?
No. So you can.
So let me see what you guys think about this. Does this help? So you need a 3, right? So I'm going to multiply my integral by 1 using 3's. So I'm going to multiply by 3 over 3. I don't know if it's going to help. I wasn't taught this way, but I thought about it the other day. Maybe this will help. So then you bring this top 3 in, because I need a 3 dx here. I need 3x squared dx, right? So that bottom 3 is going to stay outside. Is that better? To me, I was taught, and I kind of like, if I need a 3 on the inside, I need a 1/3 on the outside to balance. But then I thought, well, if you start with 3 over 3, maybe that's a little more obvious what's happening. Pull the one you need inside. And so if you needed a 1/3 inside, you would pull the 1/3 in, and the 3 would stay outside. So that general approach kind of will work for anything. So now I got 1/3 integral x squared. Well, let me put the 3 there. So what's 3x squared dx? du. I like it. So now this is 1/3. This is du. And this will be the square root of? U. Comment. And of course, to write this better, this is an interval of u to the 1/2, which is relatively easy. 1/3 u to the 3/2, so this will be 2/3, good. And now let's simplify and replace. So this is 2/9. What was u? X cubed. So always go right back up and see what the hell u was.
X cubed plus 1.
What do you be? 2 to the 3/2 plus c done. And if you to check it, you just take the derivative, which should definitely be easier than what we just did. So to check this, you would just do the derivative and see if it comes out. Real quick, if you took the derivative, wouldn't this 3/2 come down, right? 3/2 times 2/9, the 2's cancel, 3 over 9 is 1/3. And then when you do the inside chain rule, it would be 3x squared, the 3's would cancel. I mean, you can see everything that we built doing what we built it to do. Kill the shit I don't want. So that's what u sub does for us. We don't have to think ahead of time of what I need. It just puts it in the right place for us, which is like, oh, thanks u sub. Alright, so try part C. Did you get that? Alright, I get you. Near whiteboard is funny. Oh, year to year, yeah. Now I am doing the integral. Everything here was rewriting the integral problem. in a form that looks better, and then I do the inverse. Exactly, antiderivative, yeah.
Just quickly. So
Well, then you have a 1/3 there. Well, you could, right? It's 3 out, but you have to take 6 degrees out. 3 to the 6th, right? So it doesn't make it easier or look better, to be honest. I know why you're trying to do that, so you don't have to worry about that. You're trying to get more, that wouldn't even make it linear, though, so it's not really going to help. Yeah. All right, so this one, what's the obvious inside function? Which square root? So this one is inside of cosine, right? So if I let u equal x to the 1/2, what's du?